If we go back and quickly review some of the rules of exponents that we've seen recently, we know that if we multiply two terms and they have the same base, then we're going to add the exponents together. If we want to divide two things and they have the same base, then we subtract the exponents. We know that after we subtract, if we end up with a negative number in that exponent position, then we can drop it down to the bottom. Ooh, this says 7 of the fraction. And make that exponent positive. We know from the slides we were just working on that if we have an exponent raised to an exponent, that's when we multiply the exponents together. So x to the 4th cubed is x to the 12th. Now, what we're going to find out in this chapter and in this section is that these same rules apply, whether our exponents are integer values like 3s and 10s, or whether they are fractions, like they were on the last slide. So if I'm multiplying x to the 1/2 times x to the 3/8, because the bases are the same, maybe that'll work better, we know that we're going to add the exponents together. Now here when we're adding and subtracting exponents, we know that to add or subtract fractions, we have to find a common denominator. So between 2 and 8, 8's the common denominator, the lowest one. And so if we have 4/8 and 3/8, we're going to get 7/8 for this fraction. Okay. Always, just like any other time we're dealing with fractions, we want to reduce it to lowest terms, which 7/8 is. Okay, so we're done there. Maybe I have x to the 1/2 over x to the 1/6. Let's keep the numbers small here. When we divide two things with the same base, we know that means we're going to subtract the exponents. And so if we have 3/6 minus 1/6, that leaves us with 2/6. Not in lowest terms, so I'll reduce it and get 1/3. If we have an exponent and raised to another exponent, then we know that's when we're going to multiply the exponents. A positive times a negative is going to give me a negative. I can reduce the 2's here. Maybe if I click through enough things, I can get that done. Okay. And I'm left with -3 over 2. Now, if after I've added or subtracted or multiplied my exponents, if I end up with a negative exponent, then I do the same thing I did in the last chapter, and let's drop it down to the bottom and make the exponent positive. And I know this video is not very long. I should have obviously chopped the last one, but we just have a combination of, I mean, the only way to make these harder is to create problems with more steps. So maybe, for example, if I can grab one quickly out of the book, if I have x cubed to the 1/4 power on top, and on the bottom I have x to the 5/4 power, that thing squared. I know a power to a power means I multiply. Good grief, uphill, downhill. So 3 times 1/4 is 3/4. If we multiply 5/4 times 2, I get 5/2. So first we attach the exponents to whatever they happen to be attached to. Then we're going to subtract because division means subtraction. That says 3/4 minus 5/2, and 3/4 minus 10/4 is minus 7/4. And since I have a negative value, I'm going to drop it down to the bottom. Our rules are the same as they were before. There are times when we add exponents, times when we subtract, and times when we multiply. There are never rules now or ever where we divide the exponents. If you end up with a negative exponent in one of your steps, you need to make sure you have taken care of it and made it positive in the last step. And everything else is the same as it was in section 4.1.